This next problem here, they give us this polynomial h of x equals x cubed plus 3x squared minus 14x minus 12, and they tell you that 3 is a 0. And they ask you to express h of x as a product of linear factors. So all this means product of linear factors is they want you to write this basically in intercept form, okay? The reason they call it linear factors is because when you have a polynomial written in intercept form, usually anything that's inside the parentheses is going to have the highest power on x be 1, okay, just like in a linear equation. So that's where there's that overlap with the term linear. So just remember, whenever you see express it as a product of linear factors, they basically just mean find the zeros and write the polynomial in intercept form. So what we can do is copy down the original polynomial that they give us, which is h of x equals x cubed plus 3x squared minus 14x minus 12, okay? Now they tell us already that 3 is a 0, okay? And that's very helpful because we can divide x minus 3 into this polynomial and figure out what's left over. There's a couple ways to do that. You could do regular old polynomial long division and it'll work fine. It just takes a little bit longer. Or you can do what's called synthetic division. Okay, so synthetic division, we take the 0, okay, in this case 3 is that 0. We write it in this little box here. Then we write down the coefficients of our polynomial. So the coefficient of our leading term is 1, okay, then 3, then negative 14, and negative 12, okay? So we write all our coefficients down. Now, it's important to remember that when you do synthetic division, this is the same, okay? This is the same as dividing the polynomial by x minus 3, okay? And why are we dividing by x minus 3? Well, 3 is a 0. That means that x minus 3 has to be a factor, okay? Because if we plug 3 in for x, this will be 0. We multiply that into whatever's left over. It makes the whole polynomial equal to 0. Okay, so how does synthetic division work? I think we've gone over this before, but just a refresher. The first thing we do is we take this first number here after this little box and we bring it down. So we write this 1 here. Then we multiply the 3 into this 1. Okay, we get 3. Then we add. Okay, so 3 plus 3 gives us 6. Okay, then we do 3 times 6. Okay, that gives us 18. And hopefully you can kind of see the pattern emerging here. So we do negative 14 plus 18, that gives us positive 4. We do 3 times 4, that gives us positive 12. Negative 12 plus 12, that gives us 0. Okay, this is what we want to see here. Anytime a number is a 0, okay, like 3 in this case, when you do synthetic division with that 0, okay, you should wind up with a 0 in this last place here. Okay, this is sometimes referred to as the remainder. Okay, and when the remainder is 0 after you do synthetic division, okay, that means that your polynomial is evenly divisible by this corresponding binomial. Okay, so bottom line, we have 1, 6, and 4. Okay, we can use these as the coefficients of a quadratic. Okay, so we can at this point rewrite our polynomial as x minus 3, right, reflecting the fact that 3 is 0. And then we take these and make them the coefficients of a quadratic. So we have 1x squared plus 6x plus 4. Okay? Now, the question becomes, what are the zeros of this, or how can we factor this? Okay? And it looks like we probably can't just factor it straight away, so we're probably going to need to rely on either quadratic formula or completing the square. Let's do quadratic formula. So we do opposite of b, that's negative 6, plus or minus the square root of b squared, that's 36, minus 4ac, so that's going to be minus 16. Okay, all over 2a, that's just all over 2. Okay, so we have negative 6 plus or minus the square root of 20 all over 2. Okay, and from here, okay, we can rearrange this 20 a little bit. Remember, 20 is 4 times 5. So we'll have negative 6 plus or minus 2 radical 5 all over 2. Or we can divide that 2 all the way through. We have negative 3 plus or minus the square root of 5. Okay, so to write it as a product of linear factors, we have x minus 3, and then here's our two other zeros, negative 3 plus radical 5 or negative 3 minus radical 5. Okay, so we're going to have x plus radical 3 minus 5, and we'll have x plus radical 3. Whoops, I have the radicals backwards. X plus 3 minus radical 5, and we have x plus 3 plus radical 5. And that's our answer. Okay, so that's the function expressed as a product of linear factors. So to input that, we do x minus 3, and we do x plus 3 minus radical 5, and we do x plus 3 plus radical 5, and our end parentheses there. Okay, and there it is. So product of linear factors, again, the reason we use that word linear, because if you look inside each parentheses, you just have an x term, like a linear function.